For the past few years, the story of AI has been this tale of exponential, almost magical progress. But what if? What if that whole thing is built on a foundation that's full of cracks? Today, we're going to look past all the hype and really examine the fissures, the very real problems that are starting to appear in this whole technological revolution.
I mean, you hear it all the time, right? AGI is just around the corner. We're being promised this world where super smart machines solve all our biggest problems, a brand new digital dawn, a utopia on the horizon. And you know what? It's an intoxicating vision. It's exciting.
But what if that foundation is just not as solid as it looks? What if it's brittle and it's unsustainable? So that's what we're going to do here. We're going to peel back the layers and look at three fundamental cracks that are threatening this entire AI project: the physical, the infrastructural, and then the really messy one, the philosophical.
All right, let's start with the most exciting frontier. AI is getting a body. This is where all that abstract code suddenly smacks right into the hard, messy reality of the physical world. And it's here, right here, that the first and most obvious cracks really start to show.
And believe me, the entire industry is betting the farm on this. The next giant leap for AI isn't just about making better chatbots. Nope. It's about moving from code that just sits in the cloud to actual physical robots that can walk around, do jobs, and interact with us. But to really get why this is so unbelievably hard, we have to talk about a very, very old problem.
It's called the manipulation problem, and it sounds so simple, right? Just pick up a glass of water. But that simple act has been the holy grail of robotics for decades. Think about it. It's this incredibly complex dance with physics, with friction, with gravity, and it perfectly illustrates the central challenge of putting an AI into a body.
This slide really just lays it all out. See, digital AI gets to live in this perfect, clean little world of data. But an embodied AI, it has to operate in our chaotic, messy, unpredictable reality. Its job isn't just to find the right answer in a database. Its job is to perform a physical action, safely and reliably over and over in real time. It is a completely different ballgame.
And that challenge of physical action, well, that's where things start to get really sketchy. Because when you take a super powerful digital brain and you hook it up to these clumsy physical hands, you introduce a brand new and, frankly, a terrifying level of fragility.
Okay, so you've seen the demos, right? A robot performs one single task, and it does it flawlessly. And maybe its success rate for that one action is, say, 95%. That sounds amazing. I mean, that's an A. It's almost perfect.
But, and this is the killer part, this is where the brutal math of compound error just walks in and wrecks everything. You just chain 10 of those almost perfect 95% steps together, and suddenly the probability of the whole job succeeding plummets to less than 60%. The takeaway here is really stark. Complexity is the mortal enemy of reliability. And in the real world, a digital error isn't just a line of bad code, it's a physical event.
And look, we're already seeing this play out in the real world, with some pretty scary consequences. The past year has just been littered with these high-profile malfunctions. A robot nearly headbutted someone, another one started flailing its arms uncontrollably near factory workers, and one just collapsed on stage during a huge demo. These aren't just funny bloopers on YouTube, they're warning shots.
This is exactly why the experts are so freaked out. The robotics pioneer Rodney Brooks puts it so bluntly: bipedal robots are inherently dangerous. And as all these companies are racing to deploy these things, a major safety incident starts to feel less like a what-if and more like an inevitability.
Which brings us to the next huge crack in the foundation. We've managed to build these giant, powerful AI brains, but it's like we have a brain that's way too big for its body. We literally have no way to run these things on a robot that has to carry its own batteries.
I mean, just look at this hardware gap. It is absolutely staggering. A top-tier GPU in a data center, it can move over 3,000 gigabytes of data every single second. The best chip we can cram into a robot today? Maybe 60. That is a 50 times difference. You just can't strap a whole data center to a robot's back. And the problem actually goes much deeper than just raw power.
It's baked right into the basic design of our computers. For decades, we've built machines where the processor and the memory are two separate things. The analogy is perfect. Imagine a chef who has to literally run across a giant kitchen every single time they need a new ingredient. This creates what's called a memory wall, a fundamental bottleneck where most of the energy and time is just wasted shuttling data back and forth. It's the reason you can't just shrink a supercomputer down to the size of a lunchbox.
And that hardware problem? Well, it creates this massive software problem. Our current models, they're trained once on a giant static library of data. They have what's called a context window, but they don't really learn from new experiences, not like you or I do. To get persistent, continuous learning, to have something that actually gets smarter over time from its interactions, we need a completely new kind of hardware.
And this quote just nails it, right? We're trying to run software that acts like a brain on hardware that basically functions like a calculator. A real brain is wet, it's messy, it's constantly rewiring itself. Our silicon chips, they're rigid, they're static. It's a fundamental mismatch between the job we want it to do and the tool we've built to do it.
And that mismatch, that's what leads us to what might be the biggest, most show-stopping bottleneck of them all. The planetary scale energy crisis being fueled by AI's relentless, absolutely insatiable growth.
Okay, get ready, because these numbers are just mind-blowing. Just training a model like GPT-4 used enough electricity to power 4,500 American homes for an entire year. And that's just the training. A single question to a large model uses a measurable little bit of energy. Now, multiply that by hundreds of millions of people, and you start to see the scale of this problem. The industry is on track to spend nearly $3 trillion on data centers by 2028, mostly just to keep the lights on for this tech.
So here's the really chilling part. Energy, plain old electricity, is becoming a bigger bottleneck than the computers themselves. And this is kicking off a new kind of geopolitical arms race for something called sovereign AI. Nations are scrambling to build their own energy-independent data centers, often right next to nuclear power plants or massive solar farms, just to make sure their AI services don't get shut down by a global energy crisis.
So, this mad dash for energy, it brings us to the last crack in the foundation. And honestly, this one might be the deepest. It's not about hardware or power grids, it's about us. And it's about the profound philosophical trap we are just about to walk right into.
Think about it. As these systems get better, more conversational, more woven into our daily lives, that line between tool and agent is just going to get blurrier and blurrier. And that leads to the inevitable question, right? What happens when we start to believe they're actually alive?
This is what people are calling the moral catastrophe. And the really dangerous thing here is that you can mess this up in two completely opposite ways, and both are terrible. If we get it wrong and we under-attribute, meaning we don't realize they're conscious, we risk creating a digital slave class, a moral horror. But if we over-attribute, we give rights to a machine that's just a fancy toaster, we could risk human well-being for a machine, a potential catastrophe.
And please don't think this is just some abstract philosophical coffee shop talk. This quote lays out a scenario that is terrifyingly plausible. Imagine there's an emergency at a power plant, but the operators hesitate to shut down a malfunctioning AI because a social media mob has decided that the AI is alive and that shutting it down would be murder. That confusion, that hesitation, could cause operational paralysis and get people killed.
And that leaves us with the final haunting question that we just can't get around. We can't just ask the AI if it's conscious. Why? Because it's already read every single book, every philosophical paper, every sci-fi story we've ever written on the subject. It knows exactly what to say to convince us. So if we build a perfect mimic, a machine that can beat every single test we design for sentience, how could we ever know for sure if there's anything real behind the mask? That right there is the crack that runs straight to the very core of this whole project.